Hello, I'd like to thank to the meeting organizers and Phyllis for this kind invitation and the opportunity to share with all of you these new visualization tools to perform structural heart interventions. I organized my lecture to cover in 2 points, the photorealistic 3D rendering and the fusion imaging. So attending to the first point, I'd like to talk about these two 3D photorealistic renderings, the true view and the glass view. Both of them has a more close representation of the anatomy to the anatomical pieces, but more interesting has the ability to move the spotlight in any position of the 3D volume to improve and enhance the 3D perception of for the reader. But even if it's possible to place the light behind of the tissue and study any structure with transillumination capabilities. For example, on this aortic valve, we are seeing on a face view, the light is in front of the aortic valve and we are seeing the opening and the leaflets, but here the light is behind of the aortic valve. So we are studying the leaflets propriety by transillumination, and the opening is pretty clear by the light crossing through the aortic valve orifice. If we add the glass view, this transparency option that erases all this information and keep just the edge of the borders of the image and enhance the edge reference of the structures and has the capability to have an external view of a structure that we are going to see in the next slide. On the mitral valve example, we could compare the classic renders without and with color, the true view and the glass view. And it has been published that with the employ of these new renders, it's easier for the readers to identify the defect on the anatomy of the mitral valve and to identify the location and the number and severity of the jets of the mitral regurgitation, especially with the glass view. But if we place the light in other position and we could study the mitral valve with transillumination, and it's clear how is the commissure and the coaptation line, and especially, for example, when we have some problems on the quality of the leaflets on the mitral valve, especially, for example, for the Barreiro disease, it's a real useful tool. And in these two images from the left ventricle perspective of the mitral valve opening, we could see how the mitral valve apparatus could be studied with these two renders and specialized with the glass view that enhance the borders of the image. That's pretty clear, and this is how it's delineed of the mitral valve area that, for example, for a study of the mitral valve stenosis. According with the left atrial appendage, we could study the inner volume of the left atrial appendage to exclude, for example, any clot or any thrombus with the light moving to the different positions. But if we are going to use to the glass view, we have an external point of view, I said before, and it's a more likely vision, like when we are using a CT for a study and assessment of the left atrial appendage, and it's really useful for study the real anatomy, for exclude any lobe or any division that is really important for the planning and the device selection in this procedure. We are going to cover with this, talking about these new renders, these different steps and procedures, and one of the steps that are included in many procedures is the interatrial septal puncture. We need to puncture inside of the fossa ovalis, and the fossa ovalis could be located in a really easy way with the transillumination, placing the light in the other side of the interatrial septum, and you could note how the needle is just in the middle and is making a clear tenting before to cross the septum. And at the end of the procedures, many times we could detect a residual atrial septal defect that could be studied with the glass view that enhance the borders for a clearer assessment of the shape of the defect, and if we add color to study the residual sound, for example, in that case, from left to right. In the left atrial appendage closure procedure, moving the light, we could study with the creation of some shadows. For example, if the device is completely in contact with the left atrial tissue if there is any area of leakage of tension that is not completely in contact with the tissue. And for example, here in this image, according with the pulmonary ridge, moving the light from this position to an upper position, we could see there is a shadow here that is revealing an area in cover in the upper aspect of this left atrial appendage that should be surveillance during the follow-up to exclude any clot or thrombus formation. In the mitral catheter edge-to-edge repair, these new tools has many capabilities, as for example, to study the quality of the leaflets and the quantity of the leaflets that are included in the grasping, and how is the tension and the anatomy of the new orifice areas. For example, for the quality and the grasping properties, it's more useful the transillumination with a true view, and for studying the anatomy of the new orifice, for example, the glass view. And the glass view erasing the artifact of the clip is really useful as well for locating the residual jets, as you could see here, that is, for example, in that case, is immediately lateral to the clip. For the mitral paravalvular leak closure, we could study and perform these procedures with the classical renders, as you know, especially if we employ 3D color. But if we employ the true view with the transillumination, placing the light behind the prosthesis, the light crosses through the defect and is really clear where the defect is, which is the shape, and which are the measures for select the device to close this defect. This is another example, and here there is another detail, how is the added value of these new renders. Employing, for example, with the glass view, with the transparency, we could see the wall path and the channel of the residual regurgitant jet inside of the paravalvular leak, and we could select a better strategy and the device, and which are going to be our best approach to close, for example, this defect, because we could make a distinction between linear tunnels and really tortuous tunnels. And according with the aortic valve replacement, transcatheter aortic valve replacement, you know, in many centers this procedure has performed without the support of the echocardiography, but these renders have some added value and some details in concrete aspects. For example, for the study of the membranous interventricular septum, placing the light in the right ventricle, we could study in a pretty clear way which is the membranous septum, which is the length, and which is the relationship according with the aortic valve, and you know, is related with the depth of the implantation and the needs of permanent pacemaker implantation after the procedure. And for example, this is the last slide on the 3D renders. It's a really interesting slide because you are seeing here an aortic valve replacement. It's a core valve, and here there is a jet, but it's not absolutely clear if it's inside or outside the strut of the aortic valve. And employing this glass view and the color, we are seeing the wall path of the regurgitation, and with just one click with the multi-view tool, the multiplanar reconstruction are completely aligned with this regurgitant jet, and we are seeing here the struts of the aortic valve, and the jet is outside of the valve, so it's a paravalvular leak, and we could locate and quantify this residual regurgitation in a real, clear, and simple way. According with the fusion imaging, the message is really brief and really short. And as you know, we have some tools before to overlay the 2D and the 3D echocardiography over the fluoroscopy. But we have a limited field of view and the limited understanding of the complete heart anatomy over the fluoroscopy. This point has been resolved, for example, with the CT fusion imaging that has a larger field of view, and we could segment any chamber separately, and we have the complete anatomy over the fluoroscopy, but without a cardiac gating and without breath gating. So we have resolved these limitations now with the echocardiography and the employ of artificial intelligence. So employing a full volume 3D image and complete segmentation any of the chambers of the heart with the artificial intelligence algorithms and the fluoroscopy in two different projections, we could overlay a gated model fusion with separated segmentation of any of the chambers and with specific landmarks in different positions over the fluoroscopy during the whole procedure. And for example, in the mitral clip, if you have the wall segmentation of the left atrium, you have the lateral wall and all the reference. For example, here is the pulmonary ridge during the bending down of the mitral clip catheter. So it's absolutely clear that it's safer than the previous one, fusion anatomy. Or for example, in the TAVR procedures, we could have the complete anatomy and the references for perform a zero contrast procedure. Or even with the landmarks and the cardiac gating, all the time we could select the fluoroscopy projection without any milliliter of contrast employed. So the take-home messages is absolutely one message that the cardiology future goes by the hand of the transcatheter procedure. So the future of the cardiac imaging is related with that. So we need to improve our monitoring capabilities during the procedures, and we are going to employ for that high definition 3D, realistic renderings, artificial intelligence algorithms, and multimodality and fusion imaging to improve our visualization, our understanding, and as well the result of the procedures that we are involved in. So thanks for your attention, and I hope that you feel really interested in this lecture of 3D.